In this video, you will learn how to build the following clustering models in KNIME Analytics Platform, including K-means, hierarchical clustering, and DBSCAN. Ready? Let's go! Start with the K-means algorithm. In the configuration dialog of the K-means node, define the number of clusters, K, for example 3, and the clustering column. Optionally, set whether the initial clusters are the first K rows or random rows, and set the maximum number of iterations, which determines how many times the clusters are recalculated after the initial clustering. The K-means node has 3 outputs. Cluster assignment for each row in the input data, column values at the cluster centers, a cluster model for applying the same clustering to new data. Evaluate the clustering numerically with the silhouette coefficient statistics, which compares the distance within a cluster to the distance between clusters. The silhouette coefficient node calculates the statistics for each row separately and also provides an overall value as their average. The closer the overall value is to 1, the more compact and separated the clusters are. You can optimize the number of clusters based on the silhouette coefficient using the optimized K-means silhouette coefficient component. Perform hierarchical clustering using 2 methods. Hierarchical clustering node. In this configuration dialog, define the number of clusters, example 3, select Euclidean distance as the distance function, and complete linkage as the linkage type. The output shows the input data plus a cluster column for the cluster assignment of each row. Hierarchical clustering and heat map component. Determine the number of clusters visually in a dendrogram. In its configuration dialog, select the clustering columns. The component applies complete linkage and Euclidean distance by default. The interactive view shows a heat map and a dendrogram of the hierarchical clusters. Adjust the line on the y-axis to change the number of clusters and observe the heat map for similarities among rows. Perform DBSCAN clustering. The DBSCAN node takes 2 inputs, a data table and the distance matrix of the clustering columns, calculated with the numeric distances node. In the configuration dialog of the DBSCAN node, define 2 settings, epsilon, the radius of a neighborhood, and the minimum points, the required density of a neighborhood. Note that the number of clusters is not defined beforehand. The DBSCAN node's outputs include cluster assignment of each row, frequency distribution of the clusters, and noise points. Compare the scatter plots and the silhouette coefficients of the algorithms in the interactive view. Optimize K-means clustering. Separate the data into upper and lower clouds. Hierarchical clustering creates compact but poorly separated clusters using the complete linkage method. DBSCAN clustering produces an almost identical clustering to the optimized K-means clustering, except for a noise point. The table below shows the silhouette coefficients with the highest value for the optimized K-means clustering. The best clustering method always depends on your use case and preference. In this video, you have learned how to build clustering models like K-means, hierarchical, and DBSCAN using KNIME Analytics Platform.